Bet you were, Jordan.
Okay, we have a can. The volume of a cylinder. What's the formula for the volume of a cylinder?
1/3 pi something.
Wow.
Pi r squared h. Because if you've got this can, here, volume occurs from sliding stuff, right? So you take a point, you slide it, you get your line. You take your line, you slide your line, you get a plane. You take your plane, you push it back and forth, you get space. So every time you do sliding, you add a dimension. So point is 0 dimensions, slide it, 1-dimensional line. Take the line, slide it, 2-dimensional plane. Take the plane, push it and pull it, 3-dimensional volume. This is volume. Pi r squared is the area of a circle. Take that circle, slide it by your height. You'll come up with your 3-dimensional volume. Alright, so when I think of the volume of any figure, I try to imagine a shape that I can slide to create that exact volume. Alright, so you've got this circle, alright, and it slides by the height. There's your area times the height. That make sense? Sort of? Okay, so that's where that formula comes from. We also know that the volume is 2,000, so we have 2,000 equals pi r squared h. I don't really know how I'm going to use this information. I'm just writing stuff down. It says the total amount used by the can, the surface area they give it to you, is 8r squared plus 2 pi r h. So 8r squared is the area on the top of that, and 2 pi r h, that's your area around the cylinder. So if you had a cylinder and you cut it, you open it up, you get a rectangle. Here's your height, and this distance was the circumference of the circle, right? So that's where the 2 pi r comes from. 2 pi r is the circumference, that's this length of your rectangle, and the height is this rectangle. So it's just length times width again. That's where that formula comes from. All right, does that make sense to everyone? All right. Let's see, what is the ratio now? Oh, well, I have to read the problem. The most economical can. Okay. So we need to find the derivative of A and optimize it, and we're going to come up with a ratio. Unfortunately, before I take the derivative of A, let's take the derivative of A with respect to like your radius. I need to get h in terms of what variable? R. So what equation can I use to get h in terms of R? The one up here. So 2,000 over pi r squared equals h. You take that, you plug it into h. Yes. Is it 1,000? Oh, I'm sorry. I just wrote the wrong number. Are you out of that? Battery holding up?
No, we're good.
We're gonna what?
We're good.
We're good. All right. So now I can differentiate, or let's write this down. So A equals 8r squared plus 2,000 pi r over pi r squared. So moving over here. Area equals 8r squared plus 2,000 over r. Okay, so I got my area equation in terms of r's and only r's. That's good because now I can differentiate with respect to r. When I differentiate with respect to r, we get 16r plus what? Minus 1,000 or 2,000?
4,000. Multiplied by a -2.
You're taking the derivative. Negative 2,000 or the -2. When you do the antiderivative, you divide by the new power. So since we were just doing antiderivative problems, we get mixed up. So you just got to keep them straight. set this equal to 0. So 0 equals 16r minus 2000 over r squared. We can multiply everything by r squared. And we get 0 equals 16r cubed minus 2000. So 2000 equals 16r cubed. So 1000 over 8 equals r cubed. And I only divided by 2 because those are perfect cubes. I'm just recognizing it. So 10 over 2 equals r cubed. I mean, just faster than dividing. 1000 divided by 8 is 125, and cube root 125 is 5. But let's do it this way. Is this what came to my head? Oh wait, there's no cube there. So 5 equals r. You guys know 10 cubes is 1000, 2 cubes is 8? All right.
This is a rectangle.
You would not recognize it? Okay. I don't know, I'm just making things up. All right, so that is my r. So r equals 5, what is it, centimeters, inches? Centimeters. And so height equals 1000 over pi r squared, so that's 40 over pi, I guess? Centimeters. So those are the dimensions. And then we also have to come up with what? The ratio? H to r. So h over r is equivalent to, I should just say equals, the ratio is 40 pi over 5, which is 8 pi over 1. So 8 pi, is that right? No, hold on.
40 over.
Oh, yeah. That pi goes down to the bottom. 40 over 5 pi. So 8 over pi. Or you could say 8 over pi 2, 1. Yeah, actually that's a better relationship. Let me do that. That's what they want. So height is 40 over pi. Radius is 5. So that's 8 over pi. There's your relationship. All right, we're done with that.